All right, we're going to start with number 10. And it says find the x or t intercepts of this function, c of t equals 2t to the fourth. Oh wait, we already did this one. No, we didn't. 2t to the fourth minus 8t cubed plus 6t squared. And it wants us to find the t-intercepts. That's when c is equal to 0. We're going to factor. To factor this, we always want to try to pull out the biggest thing first, if we can. So the biggest number that goes into all of these terms is a 2, and the biggest variable is a t squared. Factor that out of the first term, all that's left is a t squared. Factor out of that second term, it's a negative 4t. And the last one just becomes a plus 3. Every time you factor, it's a good idea to kind of check this in your head and make sure this works. 2t to the fourth, that's the first one. Minus 8t cubed, yep. Plus 6t squared, great. We factored correctly. And we can keep on factoring. You have 2t squared. Now we have a trinomial with leading coefficient 1. Going to be t and t. And then two numbers that multiply to positive 3 that add to negative 4. That's going to be negative 3 and negative 1. So the zeros are when t is equal to 0, positive 3, and positive 1. Or the points 0, 0, 3, 0, 1, 0. Those are our t-intercepts. Use the intermediate value theorem to confirm that the given polynomial has at least one 0 in this interval. All right, 26 is actually literally the one that we did in the video, so let's do 24. F of x equals x cubed minus 9x. We want a 0 between negative 4 and negative 2. So to use the intermediate value theorem, we have to check two things. Is f a polynomial? And are f of negative 4 and f of negative 2 opposite signs? Polynomials are continuous, so if this is true and they're opposite signs, the only way to connect the dots is by crossing the x-axis somewhere. So f is a polynomial, yes, we have that. It's a power function minus another power function. Do they have opposite signs? Well, we have to check that. F of negative 4 will be negative 4 cubed minus 9 times negative 4. First thing is just become negative 64. Second thing becomes positive 36. You can use a calculator to help you figure out. This should be about negative 28. What about f of negative 2? That'll be negative 2 cubed minus 9 times negative 2. Negative 8 plus 18. It's positive 10. This one's a negative. This one's a positive. Yep, they've got opposite signs. So IVT guarantees at least one x-intercept, 1, 0, between negative 4 and x equals negative 2. Ta-da! That's how you use the intermediate value theorem. Look at 34 next. Find the zeros and give the multiplicities of each. Did that one too. Let's do 32. I don't think we've done 32. 32 is f of x equals x cubed times x minus 1 cubed times x plus 2. Well, the zeros are just the intercepts, right? That's going to be when x is 0, positive 1, and negative 2. Multiplicities is how many times each one of those happens. 3, 3, and 1, respectively. There's a little hidden 1 here. All right. 3, 3, and 1, respectively. That's all you need to do for 32. 46. All right. 46. Scroll down a little bit more. Graph the polynomial functions. Use the intercepts, multiplicity, and behavior. So m of x. Let's do this on the next page. We're going to want the full page for this. All right, this is 46. And m of x is equal to negative 2x times x minus 1 times x plus 3. All right. So we need to look at the intercepts, the end behavior, and the multiplicities. So we need to look at the x-intercepts, multiplicities, y-intercepts, end behavior. We need this all of this. The x-intercepts are going to be at 0, positive 1, and negative 3. Oh, this one's kind of boring. The multiplicities for all of these are all 1. Nah. Well, let's put those zeros on the graph. X equals 0. Oh, we already know our y-intercept, right? Y-intercept has to also be at 0, 0. And x equals 1. And x equals negative 3. Well, kind of only thing that's left is the end behavior. And then incorporate the multiplicities. Again, we've incorporated this. We've incorporated this. The end behavior, this is a cubic polynomial, third degree polynomial. There's an x, and another x. Or you could add up the multiplicities. Add up the multiplicities, you get the degree is 3. What about the leading coefficient? We have to look at the leading term. We know that there's going to be a whole bunch of stuff. Boiling it out is the best strategy. But if you just look at the leading term, you can know that the leading term is going to be negative 2x cubed. But feel free to multiply this whole thing out. The leading coefficient is negative. So cubic and negative looks like this. So it's going, whoa, going down on the right and up on the left. We've incorporated the end behavior. Last thing, let's incorporate the multiplicity. They all have multiplicity 1, which means they're all going to cross like this, like a line. And specifically, we know which way the lines are going because it has to connect, right? We have to connect all the pieces. So it's going to look something like this. And something like this. And then something like that. I didn't quite connect, but it's close enough. And again, we don't really know where this is. We don't really know where this turning point is yet. That's something that's going to come in a later math class. Check your answer. On Desmos, you should get something that looks kind of similar to this. Let's check. So this is the function. Y equals negative 2x times x minus 1 times x plus 3. Yeah. It goes down further than we thought. Other than that, matches right up. Let's do another one. My pen was backwards. Luckily, you can't see it. All right, it's 54. 54 in the book. Use the graph to identify zeros and their multiplicity. Well, the zeros are the x-intercepts. The x-intercepts are at -4, -2, and +3. Multiplicities are 1, 1, and about 2, respectively. What about number 60? Write an equation. So the degree is 4. There's a root of multiplicity 2 at x equals 4. Oh, this is another. I'm just choosing all the same ones that we've done before. All right, let's move down to 62. Degree is 3. Have I done this one too? No, I haven't done this one. Degree is 3. And there's zeros at x equals 4, x equals 3, and x equals 2. It didn't tell us the multiplicity, but we know. If the degree is 3 anyway, the multiplicities of all of these have to be 1. The multiplicities add up to the degree. Unless there are complex roots. Either way, the multiplicities can't be more than the degree. All right, and y-intercept at 0, -24. So what is our function going to look like? Well, it has some stretching factor that we don't know. It has these 3 roots. Their multiplicities are all 1, so we don't put any exponents. And then we just solve for a. Y-intercept is -24. So it gives us, multiply that out, becomes +12, -24. Oh. A is just 1. Our function really is just x minus 4, x minus 3, x minus 2. And you could check, if you graph this, that this has all the required properties. All right, 68. What does that look like? Use a calculator to approximate local minima and maxima, or the global minimum and global maximum. We talked about this a little bit. Local minimum and local maximums are these turning points. Minimums are at the bottom, maximums at the top. And global extrema is just what is the actual peak of the mountain, the actual depth of the dark. So for 68, let's graph this. Can I copy paste? I don't think so. No, you can't. You can't copy paste. All right, what do we got here? 2x cubed minus 3x minus 1. Let's look at global extrema and local extrema. So local extrema are at these turning points. Okay, so there's a local maximum of the y value of 0.414 at the x value, -0.707. There's a local minimum of -2.414 at the x coordinate, which is positive 0.707. So it's talking about the minimum and the maximum of the function. So locally, like if we're only looking at a small area, this is the biggest. If we're only looking at a small area, this is the smallest. What's the top of the mountain? Well, you better hope you're not hiking this mountain. Because you try to find the top of this mountain, you're never going to get there. You're just going to keep on hiking higher and higher. You try to find how far down we can go, you're never going to get there. Keep on going down and down and down. There's no global extrema here. It gets as high or as low as we want, right? Keeps getting higher and higher. There's no biggest number. Right, there's no biggest number. And the same thing for the minimum. Keeps getting lower and lower, etc. All right, that's how you kind of approach these ones. Let me know if you have more questions on these ones. Since we didn't touch them, like, really, we talked about the concepts, but we didn't really do any other problems like that. So feel free to reach out. Let's look at 74 to finish off. Use the graph to write a polynomial function of least degree. For this one, so this is what applications usually look like. They're not between -5 and 5. Usually applications are going all over the place with big numbers or messy numbers. These ones are actually not very messy. So we're going to do this the same way we've done things before. I don't know the stretching factor, but I know the zeros, right? There's a 0 at -300. What's the multiplicity of that 0? 2, right? It's bouncing off like a parabola. There's also a 0 at +100. What's the multiplicity of this one? 3. Locally, it looks like a cubic function. What's our y-intercept? I don't know. It's hard to tell. It's a little bit more than -1 times 10 to the 5th. Oh, I do know it. It's -90,000. All right, so -90,000 is a times 300 squared times -100 cubed. You're definitely going to want to type this right-hand side into a calculator, right? -300 squared times positive 300 squared times -100 cubed. That's -9 times 10 to the 10th. -9 times 10 to the 10th. -9 with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or you can keep it in scientific notation. But when we divide it out, right, the negatives are going to cancel. And then 4 zeros are going to cancel. And the 9 actually cancels as well to become a 1. That gives us 1 equals 1, 0, 0, 0, 0, 0, 0. Oh, the commas don't go there. Commas go here. 1,000,000. So A is just like you. 1 in 1,000,000. Ha 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 ha. All right. So I shouldn't have done this by hand. I should have used a calculator for all of this. Let's check our answer. Okay. So this is what I think our answer is, but I may have made an error. So I'm going to check it. I'm not even going to box the answer yet. Let's check it. Let's graph our function. 1 divided 1,000,000 times x plus 300 squared times x minus 100 cubed. And x is going from -400 to positive 300. X goes from -400 to positive 300. And y is going from -4 times 10 to the 5th to 2 times 10 to the 5th. -4 times 10 to the 5th to 2 times 10 to the 5th. Does this look right? Well, this 0 looks right. The y-intercept. Oh, wow. I'm actually surprised I didn't mess up. And this looks right too. These look like the same graphs. Great. I'm a little happy. Yeah, I should use the calculator. All right. Let me know if you have any questions, and that's it for this video.